Hi students, in this video we're going to look at solving simultaneous equations. First of all what they are, and then second of all how to solve them graphically. So the learning goals of this video, so after watching this video you should be able to understand what simultaneous equations are to start off with. Understand what we're calculating when we solve simultaneous equations, and then finally be able to solve them graphically. Right, some steps you'll have to remember, so solving linear equations and also graphing straight lines. Both of those skills we'll be building on in this lesson. So simultaneous equations are a set of two or more equations that are solved together. Right, so simultaneous just means things are done at the same time or done together. So what we're doing is we've got two or more equations and solving them simultaneously, we're solving them both at the same time. So when solved together, that should make the solution makes all equations that are being solved true. Now, what that might mean is, for example, let's say we've got 3x plus 2y equals 5. Okay, so one possible solution for that equation, if x equals 1 and y equals 1, that will solve this equation. If x equals 0, y can equal 5 on 2. If y equals 0, x could equal 5 on 3. So there's lots of potential solutions there between those with that equation. There's lots of potential values for x and y, but as soon as we add in a new equation, we now limit the number of options that make this first equation true and make this second equation true. Really, there should only be a maximum of one solution that makes both equations true at the same time. Now, graphically, what we're doing is finding the point where these two lines intersect. And that the coordinates of that point of intersection is the solution to our simultaneous equations. So let's do an example of solving a problem graphically. So we're going to find where these two lines cross, and that will be the solution to our equations. So we've got y equals 2x minus 3. So graphing that's pretty straightforward. Our y-intercept is -3. Gradient of 2 means we'll go 1 to the right and 2 up. And so we've got our 2 points. And there's our first line. So there's our line y equals 2x minus 3. Now for 5x plus 4y equals 40, let's just use our intercepts. So our x-intercept we'll find first. So when y equals 0, if y equals 0, 4y disappears. So it's 5x equals 40, or x equals 8. So there's our x-intercept for our second line. And our y-intercept for our next line, that is when x equals 0. That means that 5x will disappear. It'll just be 4y equals 40. And then that just means y equals 10. So our y-intercept is up there at 10. And then just drawing a line between those 2 points gives us our line 5x plus 4y equals 40. Now our simultaneous solution is the point that solves both equations at the same time. Graphically, that's where they cross. So that's this point here. And the coordinates of that point there are 4, 5. So we can say therefore, the solution of these equations is x equals 4, y equals 5, or we could just write them as coordinates 4, 5. Now we might just check if that's right. We'll substitute into this first equation. If we substitute in 4 and 5 into that equation, it'll be 5 equals 2 times 4 is 8 minus 3, which equals 5. so that equation's true. Substituting 4 and 5 into the second equation, 5 times 4 is 20, 4 times 5 is 20, added together equals 40. That equation's right too. So at that point, those values solve both equations at the same time. They're both true with those x and y values. Now, a couple of things to note. Simultaneous equations can have one solution. That's what's going to happen most of the time. So that's like, as we saw, two lines cross, there's only one intersection point there. Now, if the lines, there could be 0 solutions if the lines do not intersect. So that means if they're parallel. So if we've got y equals 2x plus 3 and y equals 2x minus 5, those lines have the same gradient, they're parallel, they're not going to cross. So they're not going to have any simultaneous solution. Or our equations could have an infinite number of solutions if they're actually the same. So let's say our first line is, let's say the equation of our first line is y equals 2x plus 3. Let's say our second line is y equals 2x plus 3. It's exactly the same line directly over the top. Imagine that line being over the top. And if those lines are overlapping everywhere, that means that their common solutions, their intersections are everywhere. So if it's the same line lying on top of each other, there's an infinite number of solutions there. That's the only 3 cases for how many solutions there might be. Usually we're just looking at this one where there's only one solution between 2 lines crossing over. So after watching this video, students, you should be able to understand what simultaneous equations are, understand what we're calculating when we solve simultaneous equations, and solve simultaneous equations graphically by finding out where they cross.